Hi everyone and welcome to the third Tracerco podcast. I'm Rob Hardy and I'm joined as ever by my co-host Bill Rivers. Hey Bill, how are you doing?
I am doing good. Rob, how are you doing?
I'm good. So this is the third one. We made it to number 3.
Hat trick.
The hat trick.
Yes, a hat trick.
So what's it called if you get 3 touchdowns? Is there anything for that?
3 touchdowns.
3
You're a really good offense. You're making the other team look really, really bad. Their defense is horrible. that's what 3 touchdowns means in the U.S.
Okay. Well, there's also in soccer. There's also the perfect hat trick, which is you score 1 with your left foot, 1 with your right foot, and 1 with your head.
Oh,
So that's the perfect one.
the only hat trick I know is in hockey, right?
Yeah.
You score 3, you get hats thrown on the ice. I think if you're in Detroit, you throw an octopus out there or something to celebrate. So, there you go, hat trick. We made it to 3.
Made it to 3, yeah. And we got some more questions as well.
Get out. Really?
Yeah, we've got 2 more questions.
From different people? Same people?
Could be the same people. Could be the same one person that sent all 4 questions so far. We don't know.
No, we're going with we have 4 fans, and by the time we do number 4, we're gonna have 8 fans, and it's just gonna roll on from there. By the end of March, we're gonna have at least 100. I can just feel it already.
Yeah. All right. So last time we were looking at the wash bed example. So we had a couple of questions related to that one. The first one was what process variables did they manipulate during the trial? So I think one of the first ones that they found had a sort of weak effect on the coking rate was the amount of wash oil that was used. So they had a low amount in the aggressive cycle. They had a high amount in the mild to reduce the coking rate. So that had a small effect on the coking rate. There was a few parameters that had no effect on the rate. So things like the charge rate, the flash zone temperature, the flash zone pressure all had no effect. But the one that was really had the biggest impact was the true overflash rate. And you can see a couple of graphs in the case study if you go back and look that show the correlation there between the increase in the bed density and the overflash rate. So I think those were the main ones. Anything to add on that one, Bill?
No, you summed it up pretty nice. Yep.
Cool. All right. Next one was, we were talking last time about the crude unit, but can the techniques be applied to different units? And I guess we had a couple of different scans, didn't we? We had the sort of single pass scan. We also had the tomography type scans, but yeah, I don't know if you want to comment on use in different units and different areas of the refinery.
Yeah, absolutely. When we go into a refinery, we have 3 different techniques when you want to scan your tower, right? We have a true scan, which is basically like a single pass. We go down through your active areas or actually any area where the customer feels they're having issues or problem, but mainly it's a one pass right through down your active area. We have the true grid, which we talked about in our first podcast, was basically 4 cords, which is primarily used on pack beds, and they scan straight down. And the last technique, which is strictly used on pack beds as well, is the through vision. That's our CAT scan technique, where we go in and the customer tells us and picks an elevation when they think they might have an issue or a problem. We set up a ring of detectors around that tower, and we take about a 3-inch slice of that tower and we represent it as a topographical kind of a map with colors.
Yeah, great. Okay. And I guess, we'll cover a lot more units as we go through the podcast series, and we'll look at the different types of scans and the different types of units that we deal with. So yeah, we'll go into that in a lot more detail. All right, let's move on to the topic we're going to look at today, which is troubleshooting of premature flooding. So I guess what we're talking about here is liquid accumulating in a column. The example we've got today is it's quite a big unit. It's a debutanizer, and it's got a bottom section of 22 pass trays. It's got a mid section of 11 one pass, and then an upper section of another 17. So it's quite a big unit, and I guess flooding in any one of these trays is going to start to cause an issue, isn't it?
Oh yeah, absolutely.
Yeah, and I think flooding is actually the most common cause of capacity limitation in a column. So it's a big issue, but I guess the thing to say at the start is that it's more of a symptom of something going wrong somewhere else. It's not the root cause, is it? It's something that presents itself, and then we need to look a bit deeper into what's going on.
Yeah, and to your point about being a root cause, it could be just about anything. When you start having flooding, you could have a tray that's completely fouled. The more common things when we see flooding that happens on like sometimes they put too much, I guess, vapor in there, and they just put it too much hot. It's not enough vapor sometimes. If you have a foul tray and you put too much, that causes fouling really quickly. But the funniest things that I've always heard at some of our guys come back in the field was when we diagnose flooding inside of a tower is months after a turnaround. The guys will come out, get called out because there's a flooding in one section of the tray, and they'll come out and they'll scan it and confirm, yep, you're right, there is flooding here. And then when they can't figure it out, the customers done all their techniques they can to alleviate the problem. They pop the top and they go inside, which you never want to do after a turnaround.
Mm-hmm.
And they come out with helmets, slicker suits, iPhones, you name it, things that people just forget. They're working and they get past them with retraying a tower, they just forget they left equipment down there. And that's a common thing that happens after a turnaround. It causes flooding.
And I guess the real advantage of what we can do is we can identify exactly where the flooding is, can't we? And we can help to form a remediation strategy that doesn't involve a shutdown or going in there.
Yeah, absolutely.
All right, great. All right, so maybe we'll just have a look at the case study that we're looking at today and jump in with any comments or anything to add as we go through it. But yeah, like we said before, it's looking at a debutanizer. So it's got a couple of C4 plus feeds, one into the upper section, one into the mid. We've got the 3 distinct areas of different towers, different trays, sorry. But I think initially this was sort of flagged as a problem with flooding. There was a few things that presented themselves. So there was a rapid rise in the pressure drop. There was deterioration of the bottom product, which was the C5 plus product. There was deterioration of the overhead product, which was the C4 product. So there's a few things going on. There was a few problems presenting themselves. And I guess our task was to go in and to figure out exactly what was going on and where it was happening within the column, wasn't it?
Yep.
I guess one thing that was kind of unique to this tower was also that there was a polymerization inhibitor being used, and I think there'd been a history of polymerization fouling, so that was another factor to think about. But initially, I guess the thing to look at was, with the gamma scanning, was the possibility that there was damage to the trays. So that was the first thing we were looking at. Interestingly, they also had baseline scans done, so they had the record of the baseline scans to refer to, see what had changed over a period of time. So again, that sort of shows the advantage of having consistent scans. Again, looking at the medical analogy, it's like having a checkbook, isn't it? Having those constant scans done and having those baseline scans to refer to. But from those initial ones, they found that there was good liquid levels on all 48 trays, so there's no internal damage.
Yep.
The next thing to look at was the froth levels, I think, wasn't it? So they found that the froth levels were generally good, except for one particular tray number 2, which had quite a high froth level. So that's sort of setting alarm bells going and giving us an area to focus on. Again, like we said before, what we could then do was adjust the type of scan or adjust the scan lines to look exactly at what was going on in the downcomers around that area. And that allowed us to diagnose that it was plugging, it was flooding in that tray, and the downcomers were plugged. So eventually we sort of diagnosed this was polymerization fouling. And again, I think the important thing here to highlight was that we were able to help with a remediation strategy because we could highlight exactly that area, and the customer actually wanted to fit a bypass line. So again, going back to the medical analogy, similar to a heart bypass, isn't it? We could tell them where the problem was, and we could help them get back on track by bypassing that area, reduce the load level on that particular tray and around that zone. So again, it's back to the medical analogy, isn't it?
It is. It kind of comes full circle, isn't it? Like, so I guess our customers are the doctors, the tower's the patient, and then you would have us, the diagnosticians, right? So we come in and we pinpoint the area of the problem, and we work with the customer at that point to see how we can fix the patient, so to speak, in order to make it run more efficiently.
Yeah. I mean, the thing that I like about that example is that we were able to diagnose exactly what the problem was, exactly where it is, but it could have been at that point that we just walked away and said, that's where your problem is, that's what you've got to deal with. But we were able to guide the sort of remediation strategy, allow them to fit that, they could fit that bypass, and they could look at then how that impacted and how that reduced the load. So it was kind of, we were involved in identifying the problem and helping with the remediation strategy as well. So it's, just shows the experience that our guys have in guiding those issues and rectifying them.
Yeah, our guys help them optimize their tower better, essentially what it all comes down to.
Okay, cool. Well, that's all I got for this week, I think. Anything to add? Any final comments, Bill?
No, I mean it was pretty straightforward. It's flooding. It's actually a really good case study. So please go to our website. If you need to get a hold of Rob or myself, we can be found on LinkedIn. Other than that, if you'd like to look at this case study for premature tower flooding, please go to our website at www.tracerco.com. Other than that, folks, appreciate it. Thank you for your time.
All right, thanks. See you next time.
See ya.
Bye. Bye.